So we want to find the residue of this function at z equals a. Hopefully it's obvious this is a double pole, because if you factor z squared minus a squared, you get z plus a times z minus a, and then that's squared. So we have a double pole of order 2 at z equals a. Now, if you notice, this function here looks like it's the derivative of, or it's closely related to the derivative of 1 over z squared minus a squared. So what we're going to do is instead evaluate the residue of z squared minus a squared, which is just a simple pole. So we can use the p over q dash method. So we'll make p 1, and q is z squared minus a squared. So we just differentiate that with respect to z. That gives us 2z. So substituting an a, that gives us a residue of 1 over 2a. And then we differentiate both sides of this with respect to a. Okay, so we differentiate inside here with respect to a to give us, that's going to give us 2a on top, and we've got a minus sign from the minus a squared, but we've also got a minus sign because it's to the power minus 1. So overall those minus signs cancel, and we end up with z squared minus a squared squared. And then we differentiate this. So differentiating this, we just get 1 over 2 a squared with a minus sign. So we're almost there, because the residue function is a linear function, in the sense that if I've got the residue of a constant times the function is equal to that constant times the residue of the function. So we can take out this factor of 2a, and if we take out the factor of 2a, we get what we want. So we take out the factor of 2a, divide both sides by 2a, and we end up with, let's just call this b1. Therefore, b1 is this divided by 2a, which gives us over 4a cubed. That's the answer.